In this video, we're going to look at lesson 10.3 on formulas in 3 dimensions. The 2 essential questions that we'll answer are how do you apply the Pythagorean theorem in 3 dimensions to find the diagonal in a rectangular prism, and how do you graph points and 3D objects on a coordinate plane. Before we get to the Pythagorean theorem in 3D, let's talk about a polyhedron. This is an important vocab word for this unit. A polyhedron is a closed figure that's formed by 4 or more polygons that intersect at their edges. The key for a polyhedron is it must be made up of all polygons. So you can see some examples here where all of the faces are polygons. These are not polyhedrons because there are some circles, and circles are not polygons. There are also curved surfaces. So to be a polyhedron, it has to be all polygon faces. So no circles and no curved surfaces like you see in spheres and cylinders and cones. All polyhedrons have diagonals. The one diagonal that we're going to learn how to calculate in this course is the diagonal of a right rectangular prism, which is going to look like this. The diagonal of a 3-dimensional figure connects 2 vertices of 2 different faces. Diagonal D in the picture is shown in the diagram, and there's a couple dimensions missing in the picture. It should be L and W for the base and the height, and then this dotted line that's blue should be X. So what you'll notice in this picture is we have 2 right triangles. For the right triangle at the bottom, if we apply the Pythagorean theorem, it would be L squared plus W squared equals X squared. And then if we apply the Pythagorean theorem for this one that's formed by the diagonal height and the hypotenuse of the bottom triangle, we get X squared plus H squared equals D squared. I'm going to make this actually simpler than what it says here. So if you use substitution and you trade the X squared in this equation with L squared plus W squared, it gives you the Pythagorean theorem in 3 dimensions, and that is right here. L squared plus W squared plus H squared equals D squared. And that formula works for finding the diagonal, but if you strictly want to find just the diagonal, what you can actually do is you can undo that D squared by square rooting each side. So you'll end up with the diagonal is equal to the square root of L squared plus W squared plus H squared. And this formula right here, you should use to find the diagonal. You'll want to use the other form where there's D squared and no root. So D squared equals L squared plus W squared plus H squared. That formula you should use if you want to find a missing L, W, or H. Finding the diagonal, it's definitely easier if you just use the one that already has the square root in it. No matter what, you're still going to have to square root at the end, but that one just works nice if you need to rearrange it to solve for L, W, or H. Both equations are the same. The first one just undoes the square root by square rooting each side. So let's try an example. We're going to use the Pythagorean theorem in 3 dimensions to find the length of a right rectangular prism. Sometimes a right rectangular prism is informally called a box. The length of the diagonal of a box that's 3 by 4 by 5, we're going to let the 3 be the length, the 4 be the width, and the 5 be the height. And you can actually put those in any order. It doesn't matter since we're going to be squaring them and adding them anyways. So looking at the formula above, we know that the diagonal is L squared, so 3 squared, plus 4 squared, plus 5 squared. And when I do that, I want to square the 3 first, which is 9, square 4, that's 16, and square 5, that's 25. When you simplify what's under the root, 9 plus 16 plus 25 is equal to 50. So the diagonal, its exact value, is the square root of 50. To get the decimal approximation, we need to put that into our calculator. Remember that if you have a scientific calculator, sometimes you need to put the decimal point in the problem. So you'll do your square root and then 50 decimal point, and that'll force your calculator to give you the decimal. You'll see like 7.071 dot dot dot. We're going to round to one decimal position. So I'm going to say the diagonal is approximately 7.1 inches. Let's try another example. Find the diagonal of a rectangular prism that's 10 by 9 by 6 centimeters. Exact same process as before. The L, W, and H are given, and I'm just going to plug those things into my formula at the top of the page right here. So we need 10 squared plus 9 squared plus 6 squared. And if you want, you can actually type this whole piece that's under the root into your calculator using the squared button. And your calculator will do the order of operations for you and give you 217. You just have to remember that you still need to square root that number. And the square root of 217, when we type that in our calculator, is 14.730 dot dot dot. I will round to the tenths place, so my diagonal is approximately 14.7 centimeters. Next, we're moving on to the second essential question, which is how to graph points and figures in a three-dimensional coordinate plane. Space is the set of all points in 3 dimensions. To graph a point in space, you need 3 coordinates. A three-dimensional coordinate plane can be formed using 3 perpendicular axes. Each point is represented as an ordered triple x, y, z. You can see an example of a point that's graphed here, where 3 is my x coordinate. So notice that I went 3 in the x direction. And then, so x is this axis, then 2 in the y direction. Y is that axis there, and then the z-axis is the vertical axis up and down. Now we're going to graph these on special graph paper, so it'll be much easier for us to do our counting when we use this cool graph paper that you see on the screen right now. I'm going to use 3 colors to help you illustrate how each point is plotted. First, let's label our axes. In a three-dimensional coordinate plane, the x-axis is here on the left, the y-axis is on the right, and the z-axis is the vertical axis. To plot a point, you can start with the x-coordinate, and this is the positive x-axis that's plotted. So when I do 6, I'm going to start at the origin, which is the ordered pair 0, 0, 0. So ordered triple, actually. And then I'm going to do 6 in the x direction. So 1, 2, 3, 4, 5, 6. And then we'll go 4 in the y direction. So from that point, we're going to go up 4 in the y direction. So 1, 2, 3, 4. And then we go in the z direction, 7. So from there, I need to go in the z direction, which is vertical. So 1, 2, 3, 4, 5, 6, 7. And our point ends right there. So that big red dot that I just made is my ordered triple 6, 4, 7. Let's do the try now as well. This has an x value of 3, a y value of 7, and a z value of 5. So for my x direction, I'm going to use blue again. So 3 from the origin, 1, 2, 3. And then 7 in the y direction. So that's 1, 2, 3, 4, 5, 6, 7. And then I need to go 5 in the z direction. So up 1, 2, 3, 4, 5 vertically. And that's where our point ends. So that's the ordered triple 3, 7, 5. Now let's look at how we can graph a box. A box is just an informal name for a rectangular prism. To graph a box with the coordinates 0, 0, 0, and 5, 3, 6, you can let the 5, 3, 6 be the dimensions of the box. So I need to start at my origin, 0, 0, 0, and that's always the intersection of the three perpendicular axes. And then let's go ahead and find 5 on the x-axis. So 1, 2, 3, 4, 5. And then we'll go 3 on the y-axis. So 1, 2, 3. And I'm going to actually just continue my box. So the 3 on the y-axis is also right here. So now for the base of the box, we have this piece here. Now we're going to be able to do the z value. And for the z value, that's going to be the height from each of the 4 corners. So I know if I were just plotting the point 5, 3, 6, I would start here 5 to the 3 and then 1, 2, 3, 4, 5, 6. But since I want to make a box, I need all of the heights from the base to be 6. So let's go to all the other corners and count up 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So those 3 points there, if I connect them together, I'll get the other base of the box, and then those vertical ones are my lateral edges here of my box. So there I've graphed a box that has coordinates 0, 0, 0, and 5, 3, 6. Go ahead and try the try now on your own. Please pause the video, and then when you hit play, the box will be posted. All right, so there is your solution. I went 4 in the x direction, so 4 this way, then I turned and did 6 in the y direction, and then up 5 in the z direction. To get the base of your box, remember once you get the y value, just extend it across, and the y value over here is also going to be the 6. And then I just went up 5 from each of the corners of my box and connected them to create the box. And that's all for lesson 10.3. Thanks for watching, and good luck as you practice on your own. Bye.